In this video, we're going to take a look at simplifying trigonometric expressions. And an important foundation here is understanding that we have these identities, these equations that just represent two forms of the same thing. So, for example, you've probably seen that tangent of x is the same as sine of x over cosine of x. That's true for any angle x, any number. And cotangent is that reciprocal. We have all these reciprocal identities. Sine is 1 over cosecant, so on and so forth. We've got these real important Pythagorean identities, and then we can get different forms of those as well. And then we have some other cofunction and even odd identities that help us when the angle is not just x. So we're going to see how we can use these to simplify some expressions. So when we're simplifying expressions, we want to take a larger expression and get it down to hopefully one trig expression without any exponents and without any fractions if possible. So let's see what we can come up with here. So here we have secant squared plus cosecant squared of x minus tangent squared of x plus cotangent squared of x, and we want to simplify this thing. Well, we have the secant squared and this tangent squared, and if we flip back to our identities, we see that there's a little connection here between secant squared and tangent squared, and a connection between cosecant and cotangent squared. So we can do a little bit of substitution here, and let's try that out. So this first method here is direct substitution, and so what we're going to do is we're going to substitute for secant squared. Secant squared is 1 plus tangent squared of x. All right, we replaced that for secant squared. Cosecant squared we're going to replace with 1 plus cotangent squared of x. And again, that comes from our identities. We're not going to go through the proof of those now. And let's just copy down this second parentheses here. And then you probably can see here we're going to have some nice canceling. Nothing in front of all these parentheses are just for separation. So we could actually just rewrite this. We have 1 plus tangent squared of x plus 1 plus cotangent squared of x. And then this minus, which is like a -1, is going to get distributed to both these. And so we have minus tangent squared minus cotangent squared. All right, and we can see, well, that's nice. Tangent squared minus tangent squared is 0. Cotangent squared minus cotangent squared is 0. And this just boils down to 1. So our original one equals this, which equals this, which equals, sorry about that, 1 plus 1. We have 1 plus 1, which is 2. So these things are all equal. So this big, ugly expression to start with just becomes 2. Another useful technique is to take an expression and change it into sines and cosines. And so here we have an expression secant of x over tangent of x. And if we remember our identities, we have a reciprocal identity. This is 1 over cosine of x. And tangent is sine of x over cosine of x. All these other expressions, tangent, cotangent, secant, cosecant, they can all be written as sines and cosines. And so a lot of times it's really useful to do that. Now here we can go ahead and multiply top and bottom here by cosine of x over cosine of x, because that's going to cancel out these denominators, and we have cosine times 1 over cosine. That's just going to give us 1. And so we have 1 on top, and here this cosine cancels with this cosine, giving us sine. And we recognize 1 over sine of x is just cosecant, actually. And there's our simplified form. So method 1 was to replace an identity with something that's familiar, but we don't really have any identities that involve 1 plus secant of x. We could change everything here to sine or cosine. That was method 2. That's still going to be ugly because we have these parentheses here. So our third method is to go ahead and multiply or simplify parts of the expression to make it more recognizable. We might say, man, I wish this was 1 plus secant squared, because I think we have something that relates to that, or secant squared plus or minus 1. We'll see. So let's go ahead and simplify this. So I'm going to copy it down. First of all, we've got secant x plus 1 times the secant of x minus 1 times cotangent squared. And multiplying out the top, we're going to distribute here, and we might recognize this is a difference of 2 squares. So we're going to have, in the end, that's exactly what we're going to have, 2 squares. So we have, the first part gives us secant squared of x, and the second part, where we multiply secant times negative 1, that's negative 1 secant. Positive 1 times secant is positive 1 secant. And those we're going to cancel out. So I'm not even going to write them down for right now. In the end, we have positive 1 times negative 1. Well, that's going to give us minus 1. So these two parentheses here multiply to secant of x squared minus 1. And then we have this times cotangent squared. Well, if we look back at our identities, we see that this is just equal to tangent squared. So the parentheses here are equal to tangent squared. Because we had, a little side note here, we had the fact that tangent squared plus 1 is equal to secant squared. That was our identity. And if we subtract 1 from both sides, we see that this can be written in a different form, and that's like this. And that's what we have up here. Secant of x squared minus 1. All right, and let's bring down our cotangent. And now we know that tangent squared is just 1 over cotangent squared. With our reciprocal identity, we get that. It works also with the squared. The squared just comes along for the ride, kind of. And now, since these are reciprocals, this equals 1. All right. And one last method, if we don't see any direct substitution that's going to help us, that was method 1. Method 2 here was to try to change the sines and cosines. Well, it already is in sines and cosines. Method 3 was to try simplifying, but we can't simplify. We got cosine cubed, and these are not like terms, so we can't add them. So we need another method, and that is factoring. So what we're going to do is we're going to take our cosine cubed of x plus cosine of x, and we're going to look for a way to factor it. And we see that there's a common factor. There is a cosine in both of them. Cosine of x. Cosine of x is actually cosine of x to the third power. So when we factor this out, we get cosine of x. That's our common factor. And what's left over is, when we take cosine of x out of here, we get cosine squared. Just like factoring out with regular variables. And we take out this cosine here, and that leaves us with the sine squared. And we know from our Pythagorean identity that this is just equal to 1. And so cosine of x times 1 is cosine of x. And so this all simplifies to cosine of x. So we've just shown that cosine cubed plus cosine of x times sine squared of x all simplifies to cosine of x. So there you have some. The nice thing is that you can take different routes, so it doesn't have to be just one way to go. Take different routes and you'll get there eventually. Good luck.